In this lesson, we'll learn about how to create conditional dynamic loops. In order to do this, we must first understand the concept underlying this powerful tool. The point of using conditional dynamic loops allows us to choose multiple methods of searching through numerous datasets and choosing to influence them based off our conditions. Starting off with the basics, loops are used to reiterate through any list, array, or range of data. We are usually looking for multiple values or data points when we are using loops. And these are the objects which you usually find yourself using loops on. The first example we'll look at is an array of 10 by 11, which you can see we have defined here at the top. With this array, our goal is to print out a list of values, which is the row number multiplied by 5. In order to do this, we must first tell our loop how many times we want it to run. We do this by using our for command, which precedes the start of our loop. We are telling our loop the following. For the lower boundary of our array, which refers to the lowest index number of our array, to the upper boundary of the array, run this loop. Our lower boundary, of course, is 0, and our upper boundary is 10. Therefore, we are iterating through our loop 11 times. Now that we have established our loop, we place what we want to do every time the loop runs. In this case, it is simply the row number multiplied by 5, and then we print the resultant value. Once this is done, we go to the next I. Now that we understand how the loop established, how many times it is to run, let us look at our variable I and what it is doing. Notice at the beginning of the code how instead of just staying for L-bound ARR, we placed for I equals L-bound. What we are doing here is assigning our variable I to the lower boundary value. However, it does not stay at 0. Note that the loop says next I as well. This means that every time the loop is to rerun itself, it increases the iteration of I to the next value. Naturally, it goes from 0 to 1 to 2 and so on. This allows our code to have a dynamic value in it, that of I. Notice that our output changes accordingly. We go from 0 to 5 to 10 as the variable I changes with each reiteration of the loop. Let's move on to loops with multiple conditions. In our next example, we're going to use multiple loops in order to check multiple conditions. If it does not fulfill all of our conditions, we do not run the resultant sub and end the procedure. Looking at the values, our values 1 and 2 represent the values that we are checking. The range that we are checking, these two values, exist within the variables RNG and RNG2. Cell 1 and cell 2 give us the ability to check the very last value of our dataset. Therefore, we are not reading the entire column including all the blank values. We are just looking for only cells that have data. Combining the RNG and cell variables, we now have concise dataset in the columns we are looking for that only contain cells that have data. Now that we have set up our dataset, let's look at our loop. The loop is slightly different from the one we looked at previously. Before, we were only looking at the boundaries. That is to say, the upper and lower limits of the size of the dataset. In this loop, we are looking at the actual cells within the dataset. When you place each after a for, it drills down one level of the hierarchy regarding your loop's limits. In this case, because we placed a range in our loop, it's looking at the cells within the range. The first condition for our loop checks whether or not the value within the cell that is currently being looked at is equal to value 1. If it's not, then we end the loop and we move on to the next cell. However, if it does, then we begin our next loop. Now that the first condition is satisfied, we move on to the next loop, which checks again the cells within our range, this time comparing the value within this cell to value 2. Same as before, if the value matches, then we execute our final summation for this procedure, which is to alert the user that there's a duplicate within their dataset, and to then exit the procedure. If the value does not match, it moves to the next cell within the range until Either it ends the loop or runs the message box command. This type of loop is more of a check. It compares values against a set of values, scans through each row at a time. In order to save time, we do not search each row individually against each value, but we use the loop to check the first iteration. If we do not run into it at all, then we save processing time and energy and simply end the loop, moving on to the next line in the procedure. However, if we do, then we do a more detailed scan into the next column to then compare against. Hopefully by now you understand how loops can be applied in a variety of ways, and how to apply dynamic values to your loops in order to make your code more concise and efficient. Hey guys, thanks for watching this lesson. I hope you enjoyed it, and if you did, I'd really appreciate a like and subscribe from you. And if you want to learn more about Microsoft Excel, check out these videos above. And don't forget to check out our website, commercecurve.com, where we have lots of in-depth finance and accounting courses available with full training workbooks. All of our courses come with complete workbooks of lessons, examples, pre-built financial models, and training video. Hope to see you there.